Okay, kids, so we're back here. We're moving on to chapter 2 here, and we're into section 2.1. A lot of this is going to be a review from grade 11 as we move away from kinematics. We still have to know it, but it's going to be in the background still. And we move to dynamics. Yes, dynamics. The study of the causes of motion. And as you remember from grade 11, motion, changing of motion specifically, is caused by the concept, the phenomenon in our universe called force. Now, a force can cause an object's motion to change. If you push something, if something's sliding after you push it, eventually it's probably going to come to a stop because of friction. Things fall to the ground, force of gravity. And the symbol is F. It's a vector. It's got an arrow hat, as you remember from grade 11. The unit is Newton, named after Sir Isaac. Brilliant, brilliant physicist, mathematician, and all other stuff probably. And the Newton, if you remember from grade 11, can be broken down into a kilogram multiplied by a meter all over a second squared. That's what a Newton is when it's expressed as base units. You might remember this comes from the equation you studied in grade 11, F net equals ma. You remember that from grade 11? Well, what's the unit for acceleration? Well, the unit for acceleration is meter squared. What's the unit for mass? Well, the unit for mass is kilogram. Well, that means if the unit for force is Newton, it's got to equal these units multiplied and divided together as such. A little review for you here. So let's try to remind ourselves. Let's try to remind ourselves of some of the forces that we learned in grade 11. Little review here before we go into this hardcore. Okay, well, one of the most important ones was F little g. What's up, G? And it's the force of gravity near Earth's surface. Also goes by another name and symbol, weight. Okay, so weight is equal to the force of gravity, in this case near Earth's surface. So W vector is equal to Fg vector, and is equal to the mass of the object, all multiplied by little g, where g is negative 9.8 newtons per kilogram. What is this? Very special thing we learned in grade 11. This is the gravitational field strength. Okay, it's gravitational field near Earth's surface. It's a vector. It points towards the center of the Earth. And it has a magnitude of 9.8, but the negative sign meaning it's pointing down towards the center of the Earth. Down. We all remember gravity, force of gravity, acceleration due to gravity, gravitational field strength. They all point downward. Okay, let's continue here as I'm trying to remind you of some of the stuff you learned in grade 11. Here's another force we talked about in grade 11, F big G. What's up, big G? Universal gravitational force. We learned this in grade 11. Now in grade 11, instead of using an R squared down here, we use a D squared. And it was used when talking about forces between huge celestial objects, like, for example, the sun and the earth, right? And how far apart they were, center to center. That was called D in grade 11. Now it's called R. And what was the mass of this object? So this could be the mass of the sun, right? Or mass 1, if you consider that to be the first object. Mass of the earth, right? Or mass 2, if you consider that to be the second object. And then we'd multiply it by the universal gravitational constant. Do you remember what that is? I'm going to have you look that up. Get you to do some work. Universal gravitational constant. We studied this in grade 11. I'm just trying to remind you of this stuff here. We'll take a look at these all in turn more closely. But right now I'm just trying to, I don't like that A. Let me fix that. Just trying to get you to, oh yeah, I remember that from grade 11. Okay? So let's continue. Normal force, Fn. The normal force is the force from a surface on an object that is on that surface. The normal force is always perpendicular to the surface. So if you've got a surface like the ground and you're standing on the ground, the normal force from the ground is pushing up on you upward. It's supporting you. If it wasn't there, you'd fall through. This happened to me actually as a young kid. I was walking on a person's porch. The porch, the veranda, okay, the deck at the side of the house. The wood was all rotten. I took a step and my foot fell through the surface. It wasn't providing enough normal force. So normal force, right, on an object that's sitting on a surface, you might remember this from grade 11, it's always perpendicular to the surface. It's what is supporting the object upward on that surface. You can get a normal force from a chair if you're sitting on a chair, from a floor if you're standing on a floor, etc. So hopefully this rings a bell. Hopefully, oh yeah, you're saying to yourself, I remember normal force. Okay, well, what else did we study in grade 11? Oh, we studied friction. And there were two types of friction. Kinetic, which we know involves motion, so force of kinetic friction when an object is moving, and force of static friction, S, a stationary object. You're pushing on it to get it moving, but it just about hasn't started doing that yet. It's stuck there. You're pushing on it, but it's not moving. Static friction. And that's what the two forces that we looked at in grade 11. Now, frictional forces are always parallel. They're always parallel to the surfaces that are causing the friction. And the friction hinders motion or the start of motion. And in grade 11, I introduced you to these two equations. And they were very special equations because they involved magnitude signs. So it was the magnitude, very important here. The magnitude of the force of kinetic friction is equal to mu k, the coefficient of kinetic friction, a unitless number. It had no units. Studied that in grade 11. All multiplied by the magnitude, of the normal force. And the magnitude of the force of static friction, look, the magnitude sign, is equal to the coefficient of static friction, also unitless. And these are numbers you look up. And that we take and we multiply that to the magnitude of the normal force. So these equations have to have magnitude signs. You can't write it like this. It's wrong. It's wrong to say the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. That is wrong. It has to have the magnitude signs. It cannot be a vector equation. The reason it can't be a vector equation is if you take a look at this equation right here, you're telling me that the vector on this side is equal to the vector on this side, and you multiply it by a unitless number. Well, vectors have direction. The only place I'm getting direction from here is normal force. The only place I'm getting direction from here is the force of kinetic friction. They can't be equal because the force of kinetic friction, if you take a look of a free body diagram, let's say this is a free body diagram. Here I am. This is a box, right? And here I am. I'm pushing this box, right? So there's my applied force. I'm pushing the box. There's the force of gravity on the object. There's the normal force on the object. And here's the force of kinetic friction on the object. The force of kinetic friction and the normal force are perpendicular to each other. I cannot equate this as a vector equation because if it was a vector equation, you'd be telling me that the normal force and the force of kinetic friction have the same direction. It can't. the perpendicular. The free body diagram here, which we learned about in grade 11, shows that. So what are we left to do? We're left to only equate magnitudes of vectors, not the direction. What's left here? What other forces did we look at in grade 11? Well, there's Ft, sometimes just written as T as a vector. Tension, an applied force, let me fix that, force from a cable or a wire or a rope. You're pulling something using a wire. When that is involved, we call the force that's transmitted through that wire, rope, cable, whatever, tension. We call that tension. So here, this was section 2.1. This was section 2, but just a little recap about forces, free body diagrams, stuff like that to get your mind refamiliarized with the concept of forces. Okay, have a great day.